think somewhere or another in there, it says something about statistics, that's plural, is the study, the mathematical, you know, the branch of mathematics that deals with all these kinds of things. What is a statistic? It's the calculation or the one singular, one description of a variable within a sample is a statistic. So this is a sample of incomes from students here on campus and professors. And one statistic is 9,600, that's the median. Okay, that's one statistic. It isn't the statistic is to sample what blank is to population. A parameter is the value for a variable collected from a sample, a population. In other words, if we do a census, then all the stats that we get are parameters. Okay? That's in your, don't you have it in your yellow sheet? What a parameter, what you come up with is a parameter. There are other definitions.
Oh, it's tera and meters, so it's the beside and measurement.
What?
That's what you guys just said?
It's a what?
Beside and measurement.
Beside in measurement.
You're looking for a parameter?
Mm-hmm.
Would be information regarding the entire population, not just the particular
Information regarding the entire population. Now, the only thing that I would, take umbrage to is the idea that it's information. May or may not inform. It's data, or it is a value representing data about the population. And we do think it should inform us. That parameter, in other words, can we get a mean of a population? A mean of a population for income? Sure. And what is that income value? That income value of the average income, the mean income, or the median income on campus here for all students and faculty. Everyone on campus today is $13,468. That's a parameter. It's not a statistic. It's a parameter because it is gotten from everybody here on campus. We don't deal much with parameters. Okay? We deal mostly with a statistic or statistics, the plural of statistic, which is also that branch of mathematics. So get it through our skulls, get it into our being to think about and become intimate with the idea of measures of central tendency. You just got to understand central tendency. And when mode is appropriate, when mode is the only thing that can be computed, it's the only thing that can be computed for what kind of variable?
Nominal.
A nominal variable. We want to describe the average. The only thing we can produce, the only thing that we can tell them is the mode. If we have ordinal data, then the most likely value, the one that goes with, kind of like bacon and eggs or something, what goes with ordinal data? The median. And what goes with interval data and ratio data? The mean But there's a big asterisk, because for any of those above nominal data, it may be the mode, it may be the median, it may be the mean that is best reported. We may want to report all three. They're all three types of averages and can give us information. You know, look what happens when we have an extreme value. What does it do to the mean? It pulls it up. It pulls it toward the extreme.
Can you say skews? Would skews be correct there?
Yeah, it skews it. Whoa, that's way back. Yeah, it's somewhere in there, isn't it? It skews a value. Whenever the mean, median, and mode are separated, we say the data are skewed. That's what skews means. Operationally, when we separate them, the data are skewed. It doesn't have an R in it, you know. Sometimes that's what we think, oh my God, I got skewed data, I'm screwed. Yeah, it doesn't have that. But look at what these extreme values, once an outlier, what it does. It pulls the mean out of whack. Yes, sir.
Can we go from skewed to kurtosis?
Oh, we could. Let's not do any of them yet. You got skewed, but I don't want to go to any of those quite exactly yet. Okay? So, first, we got to get down central tendency. You'll hear statisticians talk about the first moment. You mean that's like real quick? Just the first moment? No, it's some kind of physics. You know, if you're taking physics, they talk about moments. First moment and the second moment and all that kind of stuff. Well, the first moment is mean, median, and mode. It's the average. It's the middle. It's the typical. But just remember that average is a generic term. Mean, median, and mode are very specific and very operational. We can operationally, every one of us, if we know how to compute mean, median, and mode, would get the same thing every time we did it. Okay? But if I told you, well, just tell me the average. What's the average income? I just told you, give me the average income. One of you would get the arithmetic average. What's the arithmetic average? What else do we call an arithmetic average? Mean. One of us would get the arithmetic average, and I'd say, that doesn't describe your typical income. And another would say, well, the most common income is they don't make anything. Yeah, that's okay. And another would say, oh, 9,600. They're all kinds of averages, if you will. Make sure you understand that. Make sure you can do that. You don't have, can you calculate it? Oh my gosh. You know, you can calculate mean. Can you calculate median? You need to, we'll give some practice of that. We're not going to calculate it. We did. Can you calculate mode? You just give us the mode. You know, we find that. So the first thing, if we want to describe data and all the data that exists in a quantitative study, all the data about a particular variable, we give some measure of the central tendency. But that ain't never enough. In fact, don't ever give me just a measure of central tendency. Don't ever just give me the measure of central tendency. Well, the average grade in this on this test was a 86. That really good? Really bad? Okay, but I need to know more. What else do I need to know more? What else do I need to know about this population, this sample, other than the mean, other than the average, other than the central tendency? Let me try it like this. You know, that old frog, there was a frog that, you know, on average, he had 1 foot in something and 1 foot in another something. On average, he was fine. What were his feet in? 1 foot was in liquid nitrogen, the other foot was in boiling water. On average, he was just fine. Was he just fine? No, why not?
Those are the extremes.
Because of the extremes, because of the outness, not the central tendency, the tendency toward the center, not that central just means center, okay? Not just the central tendency, but the second moment, if you will, is the dispersion of the data, the range of the data, the distribution of the data. Oh, that goes back to that stupid stuff that we were doing up here about frequency distributions and stuff. You know, you got to give me this stuff when you give me this stuff. That okay? There is the variable is ethnicity. The values are African American, Asian, Anglo, white, Hispanic. What's the average person? We got, you know, we got 120,000 of them.
We can only take a mode.
What?
We can only take a mode out of this
We
group.
can only take a mode. If I have to describe the average person, it's African American, because that's the mode. I can only give you one value. But don't just give me the central tendency. You got to give me more. The frog ain't okay because on average he's okay. All right? What else do you have to give me? You got to give me the dispersion. The average test score was 86. Is that pretty good? Well, I guess it's okay. But if the range in test scores was from 100 to 0, and there were 6 people that made below 60 or whatever, and you know 60 is passing or 70 or whatever, that ain't so good. But if everyone made between 82 and 93, well, you know, that's pretty good in an undergraduate class. They're getting pretty, you know, taught them a bunch. Okay? What do you got to do? You got to give me the dispersion. How do we give dispersion of nominal data? What are we going to do to give you dispersion of nominal data?
Do you have to indicate all the values?
How would you give it? So you give the values. The values are African American, Anglo, white, non-Hispanic, Hispanic, and Asian American. Those are all the values. And the mode is African American. Is that the dispersion? You have to give me the percentages or the frequencies of each of those values. Okay? You got to give me that frequency distribution. Now you say, well, geez, you know, what if there were 70, 11 different ethnicities. Do I have to give all 70-11 of them? You know what 70-11 is, don't you? A lot. That's right.
You could clump in the
Granddad
age of
talked-
groups.
That's what he'd say, didn't he?
No, my little cousins say it.
Your cousin, okay, well, I'm glad I've got some help with this too, your little cousin.
You said
70-11.
Pepnitz?
Huh?
You said Pepnitz, didn't you?
Yeah, just, you know, little class or whatever you got.
That's an old word.
I don't know. You know, 70-11 means a whole bunch, a lot. What do you gotta give me? In addition to the mode, and in addition to what the values are. What did I give you up here?
A visual.
Give me that frequency distribution. It didn't have to be frequencies, it could have been percentages. Oh boy, be careful now about percentages and being affectatious. 90%. 90% of all my folks passed. What might that 90% represent? Could have been 900 of 1,000. Could have been 9 of 10. Man, if you got less than 100, unless you're trying to compare it to a big group, don't give me percentages. Just give me the numbers. Give me the frequency distribution. So the instructions here on your homework say, you know, find something in the but you may want to look in APA guide. It says, did they do it right? You may have to look at APA to see if it, we got stuff that's printed in journals and conference papers. It's trash. Do it wrong. Or do it where it rather than informs, it, I think the word is obfuscates. Huh? You like that? I love that word. To obfuscate. What does that mean?
Intentionally mislead or cloud judge.
Yeah, it clouds it. It you know, hides the realness of it. To obfuscate. I think that's a cool word. Kind of, what is that when a word sounds like what it does? You know, spit. Spit.
Onomatopoetic.
Onomatopoeia, isn't it? Yeah. And as opposed to splash. They're words that sound like what they do. Dispersion. What are the kinds of dispersions? Well, if it's nominal data, give me frequency distributions, could be percentages, it could be other kinds of ways of presenting it. I think maybe in here we talk about some of that kind of stuff of percentages and again you want to be affectatious. You want to put on the dog. Isn't that what affectation? To be affectatious means to put on the dog. I want to try to impress. And so, well, I scored in the 95th percentile. No, you didn't, doofus. An owl, what is an owl?
That's how people. That's what percentage of people are below you.
Yeah, it's a line. I learned in 6th grade math or something, the line doesn't have any width, so you can't be in an aisle. You can be above it or below it, or at it, but you can't be in it. So you may have scored better than 95% of the people, and so therefore you were above the 95th percentile. The aisle that cut the 95th from the 96th. Okay? So aisles and percentages. Or we could talk about quarters. Where did you graduate in your high school graduating class? Were you in the top quarter, the second quarter, the third quarter? or the fourth quarter. Okay? What separates quarters? Quartiles. Quarters are places, things, bunches, and quartiles separated. Now, our dadgum misuse of English, and so many people misusing them, they say now that, oh, it's okay to say that you were in the top quartile. It just makes me gag. Because you can't be in the top quartile. But it says it's okay. The university allows that. Because affectatious people used it so often that it's used. But you're in the top quarter of your class. You use those big words that nobody else uses to try to impress, when in fact all you're doing is obfuscating when you do that. So quarters, a decade. A decade is what? Is 10. So if we have deciles, okay, if you're above the 9th decile,
You're in the top 10%.
you're in the top 10%, you're in the top decile. Because that separates, there are 9 deciles that separate stuff into 10 groups. So aisles are like, and there are all kinds of those sorts of things, okay, that we talk about aisles and percentages, decades. Percentages are about what? What value of percentages or what? Yeah.
Oh, there are 100 of them.
Yeah, there's 100. Nominally, there's 100 percentages, okay? And so percentage, and so a percentile, 95th percentile says you're up near the top. But if we had 20 groups and we had whatever 20, so let me just go back to the deciles, okay? And so if we said we were at the 90th percentile, whoa, you're in the 90th percentile. You're automatically admissible to Texas A&M. Maybe not the University of Texas, but Texas A&M. As long as you take the ACT and the SAT and submit your scores, they may make you come to summer school, but you're admissible to any state school other than the University of Texas. Or you're above the 9th decile. Never heard that. But that's what deciles, the same as the 90th percentile, because it divides stuff into decades, into 10, and we call it decile. Quarters, thirds. I don't know what a 1/3 or something. I don't know if it's a tresile or whatever. I don't know. But all those other ones, we got what those are.
It's probably tertile.
Tertile, tersile,
T-E-R-T, tertile.
Tertile. Or is it tertile or is it just turtle? Or tactile.
That's back to the way they.
There's something in there that may be right. I don't know what it is. So when do we use things like quarters and percentages? We said we could use percentages with nominal data. When might we use quarters, deciles with nominal data? Any other kind of data? What would be yeah.
You could use it with data that was the second one.
Yeah, ordinal data.
Thank you.
You use it with ordinal data?
You could use it to break it up into sections, like in that example there. You could have a bottom quarter and say the bottom quarter had this average income, and then the middle quarter, the inter quarter